Hello, welcome everybody to your lesson on 3-3 similar triangles. Similar triangles are a little bit different than congruent triangles. Congruent, which is represented by this symbol, congruent, an equal sign with a little squiggly. Congruent means same size, same shape. Similarity is done by this little, it's called a tilde, it's a little wiggly sign here. If two triangles are similar, that means that they're not necessarily the same size, but they do have the same general shape. The three situations you have to identify similar triangles are the angle-angle situation. If two angles are the same in two triangles like this top angle could be 30 degrees, and this one could be 30 degrees, and the bottom could be 25 degrees, and this one could be 25 degrees. If that's the case, then you have similar triangles. If all three sides like this are in proportion, you could have similar triangles. And if two sides are in proportion and one angle is the same, then you also have similar triangles. Now, I keep saying the word proportion. What do I mean by that? Well, let me give you an example. Example 1 here, I have two triangles. I have TVU and CED. I obviously have one angle that is the same as the other angle in the triangle by those little markings. But the question is, are the sides in proportion? Well, I need to rotate these triangles to kind of keep them the same to understand what I'm doing. So I'm going to take this littler triangle here, and I'm going to definitely put the C in this corner to match that up. Now the question is, do I kind of rotate it around, or do I flip it and rotate it? Well, the way to identify that is to look at the smallest side, which is 9, and this is the smallest side, which is 27, to kind of line those up together. So I'm going to do my best here that I'm going to put the 9 here, and it really doesn't matter what shape it is as long as it's triangular. And then extending from the C through the 9, you go to the point E, and then the 10 would have to be connected to the other side, so that's in the bottom. Now that would leave me, whoops, this is an E, that would leave me with point D over here, vertex D. So now I'm going to test or check to see if triangle TUV, going in this direction, is similar to CDE going in this direction. Now I think it is, but let me check. So I'm going to do the bottom sides, 30 divided by 10, and in my calculator or in my head that's pretty easy to do, that's 3, and then I go to the other side, which is big side divided by little side. So big side of the big triangle and little and the other side of the little triangle, and this is also 3. So if these are the same numbers, and it doesn't matter if you do 10 divided by 30 and then do 9 divided by 27, it would still be 0.33. As long as these numbers are the same, you have similar triangles. So that's your test. Now this was just an angle side angle situation. I'm sorry, side angle side, because I had a side and then an angle and a side, and the sides were in proportion. The next example here, I might need to find a side. So I do have two triangles here. I have this bigger one, and I'm going to draw the bigger one, and I'm going to kind of separate these two triangles out. These are what we call overlapping triangles. So the bigger one has a side of 18 at the top, has a side of 12 over here, and then I'm not really sure what this side is, but they do share this angle right there, and they do share this angle, so I know that those are the same angles. The only thing I'm not sure about are these angles, but because of angle, I know they're similar. So let me draw the littler one right here, and the littler one has a side of 6 right here and has a side of 9, and this is my question mark. So what I need to do is I need to find the ratio of these sides. So I'm going to take big divided by little, or I could do little divided by big, and I could go 12 over 6. Well, 12 over 6 is 2. So that happens to be the ratio that all these things are. And if I want to test the top side, it would be 18 divided by 9. That also is 2. Oop, I forgot to put a 22 here. So I could do multiple things to find this question mark side, and the question mark side is the length from W to P. Probably, this is a pretty easy one to go. with, because each of these are half. So 6 is half of 12, 9 is half of 18. So if this is 22, this side absolutely has to be 11. Now, if you wanted to set that up as a proportion, you could, and if it's more complicated, you might want to do that. So I could go, let me change colors here to green. I could go left side of big to left side of small equals this angled side of big. If I go big on the top, I got to go big on the top again, divided by the question mark, which sometimes we call x, and in this case I'll do question mark. And then this is a proportion, so you just cross multiply. 12 times question mark equals 6 times 22. So either knowing what that is or using my calculator, I come up with an answer of 132. And then I divide both sides by 12. And you're still going to find out that the question mark is going to be 11, whether you do it with the proportion or whether you kind of think it through, because this one's relatively easy. This is a little trickier because now we don't just have a missing side, we've got a missing expression. Now, the directions I didn't copy, but I did say in the directions that these triangles are similar. So sometimes it'll tell you. So the only way to use these proportions are if you know they're similar. So kind of rearranging this bottom triangle to kind of look like that bigger one, I'm going to rearrange it so that I can compare the sides. See how this EF side is kind of like the shortest side? So I'm going to put that over here on the shortest side, 21. And then this 30 is this other leg. So that would kind of be a triangle just rotated a little bit, and the 30 goes over here. Now, since they're similar, they're in proportion. So 21 left side, small over big, equals small over big. Now this, of course, is going to involve a little algebra. Don't forget, when you have a proportion, you can cross multiply. So I'm going to guess I'm going to run out of room here, but let's do our best. 21, 11x plus 11 equals 30 times 77. Now that's a big one for me, so I'm going to use my calculator. And I get 2,310. 2310. And then distributive property, 21 times 11 gives me 231. Now there's an x there. And then don't forget the 21 also goes into the other 11 plus 231 equals 2310. I subtract 231 from both sides. And I go 2310 minus 231. And I get 2079. I'm going to go way up here now. 2079 equals, this cancels, 231x. And divide the 2079 by 231, and I get 9. So x is 9. Now maybe I'll ask you for x, or maybe I'll ask you for this whole side. And if I do that, you just have to actually plug the 9 in for x and simplify. So the proportion part is setting it up, and just don't forget, if you're going to go big side to small side, big triangle to small triangle, you have to do that in both of these fractions. Thanks for listening.